Okay, definite integrals. When evaluating a definite integral by substitution, two methods are possible. One method is to evaluate the definite integral first, and then use the evaluation theorem. So for instance, using the result of example 2, we have the following. The definite integral now is going from 0 to 4 of the square root of 2x plus 1 dx. And so then we have the integral of the square root of 2x plus 1 dx going from 0 to 4. When we take the antiderivative, we got 1/3 2x plus 1 to the 3/2 going from 0 to 4. So if we plug in 4, we get 1/3, 2 times 4 is 8 plus 1, which is 9 to the 3/2. Minus, if we plug in 0, we get minus 1/3 times 1 to the 3/2. So we can factor out the 1/3. We know that if we take the square root of 9, which is 3, and raise it to the third power, we get 27. And if we do the same thing for 1, we get 1. So we get 1/3 times 27 minus 1, which is equal to 26 over 3. Now, another method, which is usually preferable, is to change the limits of integration when the variable is changed. Now, number 5, the substitution rule for definite integrals. If g prime is continuous on a closed interval from a to b, and f is continuous on the range of u is equal to g of x, then the following. The integral from a to b of f of g of x times g prime of x dx is equal to the integral of f of u du, where this is g of a as the lower limit and g of b as the upper limit. This rule says that when using a substitution in a definite integral, we must put everything in terms of the new variable u, not only x and dx, but also the limits of integration. The new limits of integration are the values of that correspond to x is equal to a and x is equal to b. So here's the proof. If we let f be an antiderivative of lowercase f, then by equation 3, f of g of x is an antiderivative of f of x g prime of x. So by the evaluation theorem, we would have the following. The integral from a to b of f of g of x times g prime of x dx is equal to f of g of x going from a to b, which is equal to f of g of b minus f of g of a. But by applying the evaluation theorem a second time, we also have the integral of f of u du with a lower limit of g of a to the upper limit of g of b, which is equal to f of u evaluated at g of a, g of b, which is equal to f of g of b minus f of g of a.